Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, it's November 9, 2023, and the time is around 10:13 p.m. Okay, my topic for tonight will be trigonometry, a continuation of my long video format topic, trigonometry, and we are now on lesson number 20. Okay, let's proceed. The subject matter for tonight will be trigonometry, lesson number 20, and the title of the topic will be obtuse angles. We are done with the study of angles, and we are done with the so-called study of acute angles. So for tonight, we'll be discussing obtuse angles, meaning obtuse angles, how to get its value, and how to bring out the proper sign. Okay, let's try to define an obtuse angle. Obtuse angle is an angle in which the value is greater than 90 degrees. Okay, the value is greater than 90 degrees. It is something like this. If this is the 0 degree line, this is the 90, this is 180, and this is the 360, no, 270 rather. We'll go back to 0, so 0 or 360. That's one complete revolution. If the angle falls under the second quadrant, this angle here, alpha, if this angle here is greater than 90 degrees, we call it an obtuse angle. And there is a problem on how to get the proper values of an angle if the angle is greater than 90 degrees. If you are using your calculator, there will be no problem. But if you are using what you call this, the so-called analytical solution, the Blackboard solution, okay, we must know how to bring out the proper sign, the proper sign. The proper sign of the 6 trigonometric functions, that is from sine to cosecant. Okay, without using any calculator, we could bring out the proper sign and the proper value. Okay, I will try to erase this one. So at least we now know what is an obtuse angle. So if an angle terminates on second quadrant, and second quadrant is actually after 90 degrees, we call that angle an obtuse angle. Okay. Okay, let's try to bring out the definition of a reference angle. Reference angle of an obtuse angle. Because in the computation of the value of the different trigonometric functions for an obtuse angle, okay, if we are just using the tables before, okay, we should know the reference angle of that obtuse angle. So I will place it a reference angle of an obtuse angle. We needed the reference angle to get the equivalent values for that obtuse angle. So if we try to define what is a reference angle, an acute angle between the x-axis and the terminal side of the given angle. It is something like this. If this is the angle, right, and this will be alpha, and which alpha is greater than 90 degrees. Okay, the reference angle of this alpha here, as per definition, it should be this angle here. It should be the angle between the 0 degree line and the terminal side of the given angle. This is beta. So if this is alpha, okay, its reference angle is actually beta. Beta, the reference angle. It should be the angle between the 0-degree line and the terminal side of the given angle. That's the so-called reference angle. We needed this value here, okay, just to bring out the correct value of this alpha here, the 6 trigonometric functions, okay, with the proper sign. Okay, I will try to erase this one again. So that's a reference angle. So reference angle is the angle between the terminal side of the given angle and the 0-degree angle. 0 or 180, because 0 and 180 are the same. So the angle between the terminal side, okay, of the given angle with respect to the 0 and 180-degree line, that is the so-called reference angle. Okay, so we'll make a designation here. Alpha will be the obtuse angle and beta will be the reference angle. Okay, for case number 1, if the angle falls under case number first quadrant, alpha is not yet more than 90 degrees, so we'll go to case number 2, that is quadrant number 2. If the angle falls under quadrant number 2, where is it? Quadrant number 2, it will be this. Okay. The reference angle should be 180 degrees minus alpha. Okay. If the angle falls under quadrant number 2, beta should be equal to 180 degrees minus alpha. It is this. Okay? If the angle falls under quadrant number 3, this will be. Right? So originally, this angle here emanates from the 0-degree line. So actually, this is our alpha. Right? This one. And beta, as per definition, beta is the reference angle of this alpha here. If it falls under case number 3, quadrant number 3, beta should be equal to alpha minus 180. Right? Because beta plus 180 is actually equal to alpha. Because beta plus 180 is equal to alpha. So beta should be equal to alpha minus 180 for case number 3. Okay, we should know how to compute the reference angle, because in the computation of the value of the different trigonometric functions, okay, if you are using the table, you could not locate a value of an angle in the table of trigonometric functions before, okay, without calculator yet. The value of the trigonometric functions are actually from 0 to 90 degrees. So before, our solution was limited because we will be using this solution here, because before there was no calculator yet. But now, even though if the angle is greater than 360 or something, you just punch it in your calculator and the correct value and proper sign will come out. But we know the long method of solution of that one. Without the calculator before, we use the table of trigonometric functions. That's why we must have to, what you call this, convert this obtuse angle to its reference angle to compute for the correct proper sign and value. Okay, let's proceed with quadrant number 4. For quadrant number 4, the angle will be this one, right? So the total value of alpha, it starts with 0, it goes counterclockwise. This is alpha. And beta, the reference angle of alpha, it falls under quadrant number 4. Am I still on camera? Okay. Beta should be equal to 360 minus alpha, because what do you call this? Alpha plus beta equal to 360, right? Beta plus alpha is one complete revolution, and that should be 360. So if we compute for beta, if it falls under quadrant number 4, it should be 360 degrees minus alpha. 360 degrees minus alpha. Okay. Oh, this is the way how we solve problems before because we don't have calculators yet. Around 1970s. So if the angle is more than 90 degrees, we resort to this kind of solution. But now, even though the angle is more than 90 degrees, supposing you take the cosine of 95 degrees, 95 degrees cosine, because 95 is more than 90, right? This is now an obtuse angle. There's no problem now because you just place 95, you press cosine here, and the cosine should be a negative value. It falls under a cosine under quadrant number 2 is actually minus, right? So this is minus 0.087. So it just confirms that cosine in the second quadrant is minus, right? Second quadrant. Cosine is negative over positive, it should be negative. So whatever beta you will compute here, okay, go to the trigonometric table before, okay, there will be value and the proper sign should be, you put a negative sign because you know it's a negative. A negative over a positive will be a negative. Okay. Oh, what's next? Okay, this will now be the proper way on how to find the value in proper sign of obtuse angles, okay, under quadrant number 2, 3, and 4. Okay, we include now case number 1 if the angle is less than 90 degrees. Okay, if an angle falls under quadrant number 1, okay, this is the angle. This is the horizontal side, this is the vertical side. On first quadrant, this measurement is plus. First quadrant, the upward measurement is still a plus. Of course, the hypotenuse will be plus, right? Right? So if we try to take the proper sign of an angle that falls under the first quadrant, okay, it should be something like this. Cosine of alpha will be, cosine is adjacent over hypotenuse, right? So it should be a plus over a plus. A plus and plus will be plus. Okay? So meaning to say, the sign of an angle that falls under first quadrant, the sign is plus. Okay? And what's the reciprocal of sign? It's cosecant. So automatic, cosecant will also be plus. Okay? How about cosine? Cosine of alpha will be a plus. Now, sine a while ago is a plus opposite over adjacent, right? Hypotenuse. For cosine now, it will be adjacent over hypotenuse, so it will be a plus all over a plus. And the ratio will be plus. And to take the proper sign of secant, secant is the reciprocal of cosine, so it should be 1 over a plus. So the proper sign for a secant on quadrant number 1 will be plus. Okay? For tangent, tangent is opposite over adjacent. Considering alpha, this is opposite, this is adjacent. A plus and a plus, tangent will be a plus and a plus. So the ratio will be a plus. And to take the proper sign of a cotangent under that falls under the first quadrant, just take the reciprocal of the sign of the tangent. So 1 over a plus will be a plus. So the proper sign for a cotangent will be a plus under quadrant number 1. So if you try to notice it, if the angle is less than 90 degrees, all the signs of the trigonometric functions are all plus. Plus, 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 plus. Because this is a plus, this is a plus, the hypotenuse is a plus. So no matter what ratio you will be taking under quadrant number 1, it will still be plus. This is not an obtuse angle, a acute angle, because it falls under quadrant number 1. Okay, supposing the angle is greater than 90 degrees, the one we are discussing now. So case number 2, this will be the angle, right? So we needed the reference angle now. This is minus alpha. We needed the reference angle now because it's an obtuse already. Think that we are using the trigonometric table and how to bring out the values, right? So beta will be, if this is alpha, this is beta, beta should be 180 minus beta. Okay? Then try to place the proper sign. This is the angle, right? The horizontal component is minus. The vertical component is upward, it's plus. Of course, if we try to take the sign of the hypotenuse, it will be a plus, right? Okay? So if we now try to bring out the proper sign of the 6 functions that fall, if the angle falls under quadrant number 2, same procedure as for case number 1. Sine of alpha will be, think of alpha first, right? It should be, sine will be a plus and a plus, a plus and a plus, a plus, right? So if we try to take the sine of this, I will just copy this, then put sine of beta, right? You got it? For cosine it will be adjacent over hypotenuse, a minus and over plus. So this should be minus. Okay? So if you try to take the cosine of the reference angle, just take this sign here, negative, then take this value cosine of beta from the trigonometric table. It's now less than 90 degrees. So a cosine on the second quadrant will be minus. Okay? Any angle that falls under the second quadrant, supposing it's 120. If you try to take the reference angle of this one, should be 60, right? Okay? Should be 60. So cosine of 60, what's cosine of 60? It's 0.5. But according to our computation, it should be a negative, right? Should be negative. So, what you call this, cosine of 120, as per our computation, just try to check this one if it's correct. This should be negative sine of 60 degrees. No, cosine of, negative cosine of 60 degrees. Cosine 60 degrees. And this should be equal to negative 0.5. Right? The way how we bring out the sign before is by using this. But if you got your calculator, okay, you just press 120 here. Okay. Take the cosine. It's negative 0.5. So it seems you take the cosine of 60, but the cosine of 60 is 0.5. But as per regulation here, it should be negative, so we place a negative sign here. But on the calculator, it will place immediately the negative over there. Okay, we are not using trigonometric table. This solution here is just by using the trigonometric table. Actually, this one came out on the SAT and CAT exams. Sometimes on the short videos, they bring out this one. Okay, for the tangent, it's the same. Tangent will be opposite over adjacent, right? So a plus and a minus. A plus over a minus will be minus. So tangent of alpha will be tangent of beta, tangent of its reference angle, but it should be negative. Okay, that's the way how we bring out the proper sign. Like this one. 120 degrees, if you try to take the tangent, it should be negative. Right? Oh, it's negative. Okay? It's automatic to be negative on the calculator, but on the analytical solution on the board, okay, it will be the tangent of 60 degrees, okay, but we place a negative sign. Okay, that is by using the table, because if we use the table, we look at the tangent of 60 degrees, and the tangent of 60 degrees is 1.732, but since the angle falls under the third quadrant, it should be negative. So this is negative 1.732. Okay. For the cotangent, we'll just reverse the cotangent. It should be a minus over a plus. It should be a minus. Okay. So cotangent of alpha on the third quadrant will be negative cotangent of beta. Right? For second, you just interchange hypotenuse over adjacent. A plus over minus, it should be minus. So secant of alpha will be secant of beta, but it should be negative. It will follow this. For cosecant, it will be hypotenuse over opposite. Okay? Hypotenuse over opposite. Okay, a hypotenuse over opposite, a plus and a plus. So this is a plus and a plus. It should be plus. So cosecant of alpha will be the cosecant of beta, and its proper sign should be plus. It should follow this. Okay. For case number 3, if the angle falls under quadrant number 3, okay, this is now the angle. The horizontal side is minus, it goes to the left, and the vertical side is downward, it's minus. Of course, the hypotenuse will be plus. So the same, sine will be opposite over adjacent, considering this angle here, should be sine of alpha here, alpha here will be minus over a minus over a plus. So this is a minus. So sine in the third quadrant will be a negative sine of beta. Just take the sine of this reference angle here, but since it falls under the third quadrant, it follows the sine here. It should be minus sine of beta. Cosine, you know the definition of cosine, adjacent over hypotenuse. Minus over a plus, so this should be minus. Okay, so this will be equal to cosine of beta, but the proper sign, okay, should follow this one, so this is minus. Tangent, they are both negative, right? A minus over opposite over adjacent, a minus over minus will be plus. So tangent of alpha will be tangent of beta. It follows this sign here. It should be plus tangent of beta. It should be the tangent of the reference angle, but it must follow this sign here, plus. Meaning tangent in the third quadrant is actually plus. For cotangent, of course, it will be, it's the same. It's just the reciprocal of this tangent here. So this will still be a cotangent of beta. For secant, just take the reciprocal of this one. It should be negative secant of beta. Okay. For cosecant, it follows this. It should be negative cosecant of beta. Whatever the sign here, it follows on the cosecant. Okay? Tangent and cotangent follows, and cosine and secant, it will follow. For case number 4, the last part, if the angle falls under quadrant number 4, the horizontal side is plus, the vertical side is downward, so this is minus. The hypotenuse is always a plus. So if you take the different trigonometric functions, these are the values. Sine of alpha will be a minus over a plus, so it will be a minus. Okay, so whatever reference angle here, take the sine of the reference angle, but the proper sign should follow this one, it should be a minus. Cosine, it should be a plus and a plus. Cosine is this one, okay, over hypotenuse, a plus and a plus. Cosine and the fourth quadrant is a plus. It should be plus cosine of the reference angle. Tangent of alpha, it should be the reverse now. No, it's not. It should be a minus over a plus. A minus over a plus, it should be minus. So take the tangent of the reference angle, but you should place a negative sign. Tangent in the fourth quadrant is negative. The sign. For cotangent, of course, it will be negative cotangent. It follows the sign of this one. For secant, it follows the cosine. So this will be plus secant. For cosecant, it follows the sign because sine and cosecant are reciprocal. So this should be negative cosecant of beta. Okay, that's it, guys. So if you don't have any calculator and you're given an obtuse angle which is greater than 90 degrees, and the problem is asking what will be the signs and values of the different functions, the proper solution should be this one here. Case number 2, case number 3, case number 4. For case number 1, there will be no problem. It's an acute angle. All the signs will be plus. Just take the value of the sine, cosine of the different functions, and that's it. The proper signs are all plus for case number, or it falls under quadrant number 1. Okay, that's it, guys. That's the proper way on how to bring out the value of the so-called different trigonometric functions if we are given an obtuse angle. Okay, good evening from Los Angeles. Professor David Jaderos.